All right, so we're going to look at multiplying and dividing rational expressions. So first, we're going to combine them by multiplying and dividing. So our launch, we just need to multiply some fractions. So some misconceptions that I heard about multiplying fractions, some people try to cross multiply or find a common denominator before you multiply. And it's pretty simple. You just multiply the numerators and multiply the denominators. So 2 times 1 is 2, and 3 times 3 is none. Same idea for B, 3 times 1, 3, 8 times 2, 16. Now, there's a couple different ways that I want to show how to multiply this. So some people did 3 times x plus 2, and then divided by 6. Some of you guys distributed that. So you said in the numerator 3x plus 6 over 6. And I want to show you an easier method. So here we have 3 divided by 3. That actually cancels out and makes 1. So in the numerator, you could have x plus 2 over 2. And using that idea here for letter D, if I have x squared and I divide that by x, that's going to make x. And 4 divided by 2 makes 2 in the numerator and 1 in the denominator. So 3x times 2 is 6x over 1. It's a little sloppy. Let me rewrite that. That's 6x over 1, which reduces to just 6x. So in multiplying rational functions, couple things here. The numerator, we just multiply our numerators and multiply the denominators. Well, first, I notice here that x squared minus 4, I can factor. So if I can factor that, that's going to be x plus 2 times x minus 2. And then here in the numerator, we have x plus 2. And then I just combine with and multiply by x plus 1 and x minus 3. And then in the denominator, we have x minus 3, and then times x minus 1, and x plus 2, and x minus 2. Then if you look, I can cancel out or divide my x plus 2s and my x minus 3s. And I'm going to note there that x can't be 2 or 3. Also, if I cancel them out and they disappear from the simplified equation, I know that that's going to make a whole at x equals 2 and x equals 3. And then in simplifying that out, we have x plus 1 over x minus 1 times x minus 2. Oh, and I'm sorry, that whole would actually be at x equals negative 2. Because negative 2 plus 2 is 0, and then there 3 minus 3 is 0. So sorry, I misspoke. And then lastly, the simplified equation reveals we have x plus 1 divided by x minus 1 times x minus 2. So we have an asymptote of x equals 1 and x equals 2. So now what I want for you to do is pause the video, factor, and then simplify. So I'll give you a little second to do that before I start the problem. So if I factor x squared minus 8x plus 12, we're looking for factors of positive 12 that add together to be negative 8. So that's going to be negative 6 and negative 2. So to combine that, we have x minus 6 times x minus 2. And then 4x plus 16, I can actually factor a 4 out. So I'm going to put 4 times x plus 4. When I simplify, I'm going to bring that 4 to the front. And then x squared minus 16, well, that's that plus and minus pattern. So we have x plus square root of 16 is 4, and then times x minus, and then again that 4. And then here I'm looking for factors of positive 4 that add together to be negative 4. So that's going to be x minus 2 times x minus 2. So I'm going to cancel out the x plus 4, cancel out the x minus 2. So we're going to have x minus 6 divided by x minus 4 times x minus 2. So our domain restrictions, x is not equal to 2 because we canceled that out for a whole, and x is not equal to negative 4 because we canceled that out as well. So now that we've done multiplying, we're going to move on to a dividing example. So first, a lot of you learned in middle school, you had the copy dot flip. I never wrote flop, my bad. Flip when you're dividing fractions. So we'll use that idea. We have x squared minus 9x minus 10 over x squared plus x minus 6. And then instead of dividing, we multiply and then flip. So we have x squared minus 4 over x squared minus 1. And now we just need a factor. So we have factors of negative 10 that add to negative 9. Well, negative 10 and 1. So x minus 10 times x plus 1. And then if I'm looking for factors of x squared minus 4, I notice that that's going to be x plus 2 times x minus 2. Because that's a plus minus pattern, there's no x term, so I can just go x plus the square root of 4 times x minus the square root of 4, and the square root of 4 is 2. So now if I have this and I need factors of negative 2 that add together to be positive 1, we would have x plus 3 times x minus 2, and then here x plus 1 times x minus 1. And then canceling out, we would have x minus 10 times x plus 2, and then divide that by x plus 3 times x minus 1. Now, this problem looks really complicated. So what I'm going to do is just rewrite it. I can have these two, and then instead of writing that with a big division bar, I'm going to write that with the division sign. So x squared minus 1 divided by x squared plus 5x plus 6, and then divided by x squared, and I'm just bringing this up here, minus 3x plus 2, all over x plus 3. And then I'm going to do copy, dot, and flip. So x squared minus 1 over x squared plus 5x plus 6, and then times, and then flip it, x plus 3 over x squared minus 3x plus 2. And now I just need to factor and simplify. So x squared minus 1, again, that's plus minus pattern, so x plus 1 times x minus 1. And then I'm going to factor the denominator. X squared plus 5x plus 6 is going to be 3 and 2, so x plus 3 times x plus 2. And then in the numerator, we have x plus 3. And in the denominator, x minus 2 times x minus 1. Then I'm going to cancel out what needs to go away. So x minus 1 can go away. X minus 3 goes away. So we have x plus 1 divided by x plus 2 times x minus 2. So don't forget to do your assignment.